Hi folks, today we're going to look at how to use ClickHouse and Hasura together to build a sort of a generative AI enabled application. I'm Shahid, I lead the engineering team for Hasura Cloud, and we have recently started using ClickHouse for some of our observability data that is generated by users on Hasura Cloud. We have been exploring how we can make some of the SRE task faster by using the data that we have and trying to make sense out of it using generative AI tools like OpenAI and ChatGPT. And we have been trying out a few different things, and I wanted to showcase a use case that we have tried out recently. This is a very early stages of this. We are just exploring this area to understand what is possible, just to figure out what kind of tooling we can build in this space. Nothing more than that, right? We are not trying to do anything more than that. It is a very early stage demo, so there are going to be a lot of rough edges, but just to showcase what is possible, I'm going to present the use case here. The big challenge we have is around authorization and security. Compliance is very important, so that means we need to make sure that the data that we have is available only to authorized users that we have. We need to make sure that Hasura employees are able to access, or even the AI agents that we use are able to access only the data that they're allowed to access. We have a ton of enterprise customers, and it can get pretty complicated to ensure right permission rules are set up to make sure that we don't leak we don't leak a customer data to unintended places, right? And ClickHouse plus Hasura gives a nice way to do that, and we'll explore that in this talk. So the goal here for me today is to demonstrate how do we quickly build AI-enabled secure internal apps. And again, is a very early stages of this exploration. So this is just to introduce possibilities of what is possible. Just to introduce what is possible, right? We all love ClickHouse. ClickHouse is a great database to run some real serious analytical workloads. It's super fast. You can ingest tons of data, and then you can run real-time queries on that. You can run aggregates in real time on that, thanks to all the work that went into this columnar database. It's an amazing tool if you are dealing with huge amounts of data, if you're dealing with a lot of analytical data, and you want to do a lot of aggregations on top of it in real time and super fast response times. ClickHouse is the tool to use. So we need to use the data in ClickHouse to build some cool stuff. And what are we going to have? We're going to have multiple tenants in the same database, right? Data from different teams or different projects or different customers in the same database. We have different teams needing to access certain parts of the data. We have web mobile apps that are used by end users, and you need to probably show some data coming out of ClickHouse on the screens of these end users applications, right? It could be like a monitoring dashboard or a metrics graph that you need to show for a customer which concerns their own data, right? You could also build AI apps, right? That's the LLM hype wave that's going on right now. Lots of possibilities, lots of use cases, lots of room for imagination, creativity, and we all need to access the data that is there in ClickHouse to be able to enable or build these apps. So what do you typically do? You have data in ClickHouse, you want to expose it to the end users. You would write a microservice, right? You would pick your favorite programming language. Maybe this choice of this language is decided by the support for the SDK or the kind of client libraries you want to use, and the tools you want to interact with, the support for client libraries in that language for those tools. Familiarity with the language, all of these can influence this choice of microservice. But what you want to ensure is that you are building something, you are building an API that exposes that is going to be highly concurrent, and it's going to provide low latency access to the data that you have with authorization, right? That's specific to your business use case. That's what your goal is when you're building this microservice. You want to expose a high concurrency, low latency API with authorization. And if you were to write this code by hand, we all know that's going to take time. Well, we need to just, instead of building cool things, we are building APIs, right? Building APIs are important, but we all know it's boring, right? It's not really like a good use of our time, I would say, right? But it's important. We need to do that to build cool stuff, but boring side of building APIs would be the most boring side of it, right? Figuring out the database schema, figuring out your user interface and building that, and then figuring out your interactivity. Those are all the cool stuff. Building the API to access the data out of that database to just show it on the customers on the end user end, that's the boring stuff. And building the cool stuff is where all the fun and money is, right? This is where Hasura helps you. Hasura can give you high concurrency, low latency APIs with authorization on ClickHouse with a few simple clicks, right? That's what I'm going to demo now. So what I have is, I have a Hasura cloud project. So what I do is I head to cloud.hasura.io, I sign up, and I have a project. Here I'm going to use this particular project. I will launch the console, and I have the console open here. And this is my Hasura project. So ignore all of this stuff here. We'll come back to this. So now what I want to do is I also have a ClickHouse database. This is my ClickHouse database. So I have a ClickHouse cloud account where I have a ClickHouse database, and I have a few tables here. I have a requests table where there's a bunch of requests that have been captured from my system. This data is synthetic, so don't worry too much about it. This is not real data. Let me just refresh this page so that I can get the latest information here. So I've generated some data, and this is just dummy data, so you might see something that is not unexpected there. So we'll see. So I have some requests. The dataset I'm going to deal with today is the requests coming in. There are CPU or usage metrics coming in from my servers. So the servers are processing these requests, and then for a certain time period where there were an issue, we have created a particular incident table where we are capturing those incidents. So let me just open up my ClickHouse cloud account. Looks like it's going to take some time. In the meanwhile, what we can do is, so we have the ClickHouse cloud endpoint available. Yeah, okay, this is here. Wow. So this is my incidents table where there are a bunch of incidents defined, right, for a particular time period. There is a request table where I have captured a few requests from metrics from a few projects and a few servers. Don't mind the memory and CPU going into negatives. I'm not operating at negative memory and CPU. This is just synthetic data which we did not give enough attention to on how or what the functions that I've used to generate the data are. We also have some aggregated server metrics. This is basically ClickHouse is aggregating this over all the servers. And what I'm going to do now is I'm going to connect this to Hasura. So how do we do that? Hasura exposes a system called data connectors, and what that does is anybody can write a data connector to expose a particular data source, which could be a database, could be an API, could be anything, to Hasura. So what you can do is you can come to Hasura, you can connect a database, and there are a few default built-in ones available, and there are custom data connectors that you can build which will make your own data sources exposed to Hasura. So you can see Hasura v2 ClickHouse here. There is a VV8 connector. These are all connectors that are custom. So I'm going to introduce the Hasura ClickHouse connector here. So ClickHouse GDC v2, this is an open source connector that started out as a hobby project by Benoit, one of our engineers, and then it just caught on as a full-on data connector. So this data connector can be deployed onto Hasura using Hasura CLI. So what you need to do is grab the URL of the branch that you want to deploy. Just copy that URL. Head to your terminal, install the Hasura CLI, and once you have it installed, run this command called Hasura connector create and give the URL, GitHub URL as a URL. And then you press enter. The connector is going to get deployed, and what you are going to get in response is Hasura connector list. You are going to get, these are all the connectors that I have deployed, so this is the particular one we need. You're going to get a URL for that connector. So you copy that URL, and what you do is come back to Hasura console, and then on this screen you have a data connector agents section. And here what we do is we add an agent, we give it a name, we give it a name called ClickHouse, and then you enter the URL of the connector that we just deployed and click connect. So that will show the connector as available here. You can see this, and what this does is it will make a Hasura v2 ClickHouse option available here when you try to connect a database. So among all the other databases that you have available, by adding that agent, now you have ClickHouse as an option. So you connect an existing database, you give it a name, so I'm going to call it SRE, and then you give it the password, the URL, and the username that you're going to get from your ClickHouse dashboard. So you get from the dashboard you get the URL and the password, and then you'll be able to configure that particular data connector, particular database. So I have ClickHouse SRE database added already. As you can see, my password is now shown. Okay, it doesn't matter, I'll change it. The URL and the username is also given here, and then the database will appear over here. Now you can browse the database just like you would do on the ClickHouse console. You can browse the database, you can see the request table, I can see the rows from the table, and I can modify the table, etc. Yeah, I can like edit the columns, I can do some bit of a thing here. Cool. So now you have tracked a particular, you have added the database, and then the immediate thing that you would do is once you add a database, you would track those tables. Tables would show up, and then you would track those tables. So for example, this table would be appearing as untracked, and then what would happen is here, okay, let me see, untrack the table, let's see what happens. Oops. Okay. So yeah, you will be able to like find all the tables that are not tracked here, and then you'll be able to track them, and then they'll show up as tracked tables here. Good. So now I have my ClickHouse database added to Hasura, but where is the amazing bit, right? So now all you did was create a database, launch a connector, connect that connector and the database through to Hasura, and you now have the API. So if you can see here, you can write a query to get all the incidents right? And then say get some other fields like what are the other fields in the incident table? So incident ID, request ID, and timestamp, right? So I'm going to get these things. I'm going to remove this A. So I can see now I can execute this query and I get a response back. So this data is now coming from ClickHouse. So I'm able to like just connect a few URLs together, and I'm now able to query ClickHouse. Now let's try another table. So let me show you what the request table is about. So if you go to the request table, this is a table where there is a column called project ID, and you can see that there is project ID 1, 2, 3, and each row in this table is belonging to a particular project. And what I can do is I can define permissions. So I've defined a role called SRE, and what this means is for my SRE team, I'm defining a permission where they are only allowed to select rows with a check, which is project ID. The project ID in the row should be equal to this variable called Hasura project ID. And then if that matches, they're allowed to select all these columns. Now what does that mean? So this header that I have here, this Hasura role and Hasura project ID, these are extra headers that I'm going to set. These headers now can come from any authentication system that I have. So when I have this API exposed and I have an authentication system set up, which can be a JWT token, JWT or a webhook that is configured to resolve a cookie or any other kind of token, that resolution of that token would result in these variables. So if I am authenticated as SRE with access to project 3, my cookie would resolve to these two variables, and that would be sent along with the request to Hasura. And Hasura can basically, if you just send the token, Hasura can be configured to resolve these variables itself. Now when I try to query requests, right, and if I say project ID and request ID and say another execution time column, if I make this request with this particular variable, variables, I'm only going to get like project 3 requests belonging to project 3. Now imagine the authenticated user was had access to project 2. The same request without any configuration on the request would be able to run the query without any modification, but they are only going to get project 2. So you now have APIs on top of ClickHouse with authorization, and by just configuring a certain authorization rules on the table, right? Now what you can also do is, let's imagine like you have a Postgres table. So this is a database that I have. So if I go back to my data screen, I have a Postgres database, I have a ClickHouse database, I have another ClickHouse database. So now imagine I have a project table in Postgres which had a project ID and URL, project 1, 2, and 3, and I have relationships here. I have refined a relationship here which says my project has a relationship called requests, which maps to the SRE database, which returns an array by this relationship. So my ID in the project table is gonna match with the ID in the SRE in the SRE table. It's gonna match with the project ID column in the request table, right? You can see the SRE/request table. So when I do this, I can now execute queries like, I can start from the Postgres DB and then I can query down to the ClickHouse database. So I can make queries like project. So if I let me just exit out of this permission. I have not added that permission there, but it will work the same way. Project ID URL, and then I have now requests. Now under request I can get request ID, execution time, and I can execute this request and I get the same results. So I can do joins across different databases, and I can get the data in the same request, right? So that's what Hasura does for you on top of ClickHouse. Hasura gives you APIs on top of ClickHouse, and you are able to like link all your data sources together and form a unified API with permissions, all with a few clicks on your console, right? And all of this is declarative. Everything you do here is being captured as a declarative metadata. You can download it, you can edit it yourself, you can modify it, you can check it in your version control, and then you are able to do all of this repetitively, right? You can apply it in a different project, etc. You can see everything is over here in this JSON file. So let's go back to our slides. So we saw the Hasura demo for ClickHouse, and we have data in ClickHouse, and now we have a way to access this data securely, right? So what do we now do with this data? So that's where we were experimenting with this use case, and we have a very simple demo, which is a very I would say it's a very naive demo. It's still in very early stages. We are trying to like work this out. And for this second part of the demo, I'm going to use another tool called the Hasura Notebook. So what Hasura Notebook is, it's again a let me show you how that works. So what I do is I do Hasura Notebook create using the Hasura CLI, and when I execute this command, I get Hasura deploy something called a notebook. Now I'll show you what the notebook is. So if I go look at Hasura notebook, I think status, yeah. If I execute this, it's going to show me like the status of the notebook that I have deployed currently. So it's active, and I go to this URL and I have a username and a password, right? So I'm going to go to that URL. So this is the URL, I have my notebook. So this is a Jupyter Python notebook and an API server, both together packaged into a single web service that you can deploy onto Hasura. You can use Hasura CLI to deploy this, and the code is open source. It's available here. It's basically a Jupyter notebook with Jupyter kernel gateway, which is going to take that notebook and expose it as an API, which now you can use in many different ways, and that's where it gets interesting. So this Python notebook gives you a space where you can just write Python code, chain different things together, and then you can make a few things happen, right? So I can launch the notebook here, and the notebook is going to open up. So you can see all of these notebooks that I have. And the important one that I'm working with currently is the server notebook, right? So what happens here is I can write Jupyter code blocks like this, and then basically this just returns hello world, right? Let me just remove this, and I can save this notebook, and I can add a tag like this. I can add a comment like this, get/hello world, and that is going to expose an API at /hello world where it is going to return this JSON. So now when I go back to my notebook homepage and I say restart API, it's going to start an API process in the background, which is going to now expose this particular code block in Jupyter Notebook as an API. So what I can do is I can click the test API, and then I can see the hello world. I can see hello world in response, right? You can see the URL is invoke hello world. And whatever URL I give here as the comment, that's going to be exposed as the API. So that's the interesting bit about this Jupyter Notebook and Jupyter Kernel Gateway. Amazing open source projects, very useful for the kind of work that we want to do. So now what I have here is, what I'm going to do, I have some data in ClickHouse. Now I'm going to explore if I can write a prompt that is going to include some of the aggregated data coming from ClickHouse. So ClickHouse, I've set up queries which would aggregate the raw data, and I'm going to see if I can get that data from ClickHouse and then make a request to OpenAI and see if the OpenAI, the ChatGPT for agent can help me debug or understand or run an RCA of what is going on, right? I want to understand like what is actually going on with this data. So, but if this, you can imagine if there are a lot of data sets and huge amounts of data, how would I actually figure out what the actual problem is, right? It might just be hard. Maybe like these large language models can figure something out that we are not able to just spot, or maybe it can help us like using all the training data it has. It can probably spot patterns and tell us maybe look at this or look at that, and then help us guide to a root cause analysis. So I have some boilerplate code here. What I'm effectively doing is I'm making this query to Hasura to get the data, and so now we can see that this is the context at which this is executing, right? We saw earlier that you can set a role and an ID. Now this can come from the context of whoever is authenticating. Now imagine a use case where the query itself is generated by the language model. It's quite easy for the language model to generate a query which is going to select something that it is not supposed to select, and that's where Hasura's permission model is going to be useful. It can restrict what data this language model has access to, right? Especially if it's generating the data. Now, what this is doing effectively is making a query to get the request, making a query to get some stats for the system at the same time, and putting all of that together into this function. And this is the prompt that we are making to OpenAI. So you are provided with the request and server stats, right? And then this is the request data, service data, the server stats, and then analyze the data step by step and list down analysis in paragraphs, root cause analysis, and next steps to resolve the incidents, right? And this is what we are going to execute. Now this particular bit is being exposed as a different API now, for example a post request to handle query. So any post request coming at /handle query is going to be available. It's going to execute this function and then respond with the answer that OpenAI came up with for this prompt, right? Now this is like a playground, so you can basically, instead of doing this, you can just do like here. If you see, so right now here I'm doing json.loads request, etc. Instead of this, what I can effectively do is let me just write print handle query, and I can ask the question, right? So handle query, and the question I'm expecting in a format here. So request body input of question, right? So I can do like this. What is, yeah, body is a key, and I have input, and I have question. So I have to do this because I wrote this function to be able to use from an API. So imagine my question is now run analysis for incident 2. Now if I were to execute this, my API key is wrong, it seems. So let me just refresh this, restart, and run all cells. So now let's see what happens when this particular block runs, right? Yeah, so you can see like this prompt coming in from OpenAI, right? So this same prompt, now this came from ChatGPT. So now if I were to change this to indicate, to just go back to my API that can be exposed, and I'm going to save this, and I'm going to click my restart API. So the API is going to get restarted. Now what I'm going to do is I'm going to actions tab on Hasura, and I'm going to write an action called ask question. Now this action, what it does is it exposes a mutation. So you can see type mutation, ask question, takes an input, and then it gives an answer as an output. And it's going to be linked to this endpoint, my API endpoint, which is handle query. And I'm going to add a basic authorization so that I don't get spammed by everybody else, and then I want to save it. So now I can come back here and I can run this mutation, which is going to send that request over to OpenAI, ChatGPT. Looks like I have a problem here. I'm getting a 504. Let me try that again. Sometimes the container gets shut down, and then I need some time for it to get started back up. So let me see if my API is running. Okay, looks like my API is running, and I'm going to try this again. Okay, looks like this time it's going to work. So the API was not running yet. So now it's going to send all of this data, query ClickHouse through Hasura, get all the data, make a query to LLM, and then get back with a analysis, right? So now you can see like it's come back with an analysis. So based on the analysis, here is the data, here are some key points to consider, and then what it finally says that compare, it gives us other steps, right? This might involve optimizing code, server configuration, consider implementing. So based on the amount of data that you give, you can do all sort of things with the LLM, right? Now the important bit now here is that with just a bit of code here in this notebook, you can quickly put together some application. You can expose it as an API. Now that API is available over your GraphQL API here, along with your all other APIs and ClickHouse data that you have, you can now expose it over a Slack chatbot or a internal web application that you have, and make it available for your internal consumers with authorization, right? So let's go back to our slides now. So what we see, so we saw that GraphQL is a great API to fetch data from ClickHouse using Hasura, right? And also to enrich data with other data sources. So we saw we could enrich the Postgres data with data from ClickHouse, and then you can work with all of this together in an easy way with authorization, right? Hasura is used to get a secure API, GraphQL API, instantly on top of ClickHouse using the ClickHouse connector for Hasura. Try it out and let us know how that is. And use the Hasura notebook to build an AI application, put together an AI application in a few lines of code, and then we were able to expose it as an API as well. So that's the demo today. And reach out to me to talk about GraphQL, ClickHouse, and AI. You can email me at shahid@hasura.io. I'm on Twitter at the right shahid_k, or rather today now I'm on X at shahid_k. That's a wrap. Thanks for listening. Yeah, reach out to us if this is interesting to you. Talk to you soon. Bye.